We're going to take a look at question number 1. This is about arranging light bulbs R1, R2, and R3 with given resistance in such a way that R1 and R2 are in series with each other, and then the two of them are parallel to R3. They're connected to a 30-volt battery, and we have to find out the current and the voltage drop for each light bulb. And then we have to determine which one is the brightest. So we are going to go back and try to review very quickly now some of the main principles and things we need to know. So remember that this is in series, like this circuit has the 3 resistances in series. This has 3 resistances in parallel. That's how they look. And when it comes to how resistance, voltage, and the current are related to each other, well, they're connected, all of them, by the total voltage is going to be equal to total current and total resistance. But when in series, then we're going to say that the total resistance is going to be the sum of all of them. So R1 plus R2 plus R3. Now, in parallel, we have 1 over RT is going to be 1 over R1 plus 1 over R2 plus 1 over R3. Now, if you have more resistances, obviously, then you make the formula a little bit longer. Now, when it comes to current, the current will be the same throughout the circle when in series. So I1 would be equal to I2 and equal to I3. Whereas when we are in parallel, we have the current different for each and every one of them. So I1 will be different than I2 and different than I3 depending on the value of the voltage. Now, for voltage, though, on the other hand, here we have the voltage the same throughout. So the voltage in V1 is the same as in V2, same as in V3, and it is equal to total voltage. Whereas here, the voltage is going to be equal to the sum of the voltages in each resistor. Okay, so and for current, actually, so they are going to be different. I'm just going to leave it in there, and the total is going to be equal to the sum. So I1 plus I2 plus I3. So with this in mind, we're going to start solving this problem here. So we're going to write down the information given, and we're asked to find out what the current will be in each bulb and what the voltage will be in each bulb. And at the end, we have to determine which one is the brightest. When it comes to which one is the brightest, we have to look into the power of each bulb, and the power is equal to I square R. Okay, now, first of all, we are going to draw the circuit as described in here. So we place R1 and R2 in series, and then R3 will be parallel to the first two that are in series. Now, in order to determine all the unknowns in here, we will need to work with the main circuit, which is going to be, the main circuit is parallel. So this is series within a parallel. So in order to determine the current and voltage drops, we need to simplify this. And the way we simplify it is we make these two series into one. So when in series, we add them to each other. So we're going to call this the R12, which is going to be equal to R1 plus R2, and that's because they're in series. And that would be equal to 14 plus 6, and that's where we get the 20 from. Then R3 is right here. Now, next, we will have to determine the total resistance. So the total resistance is found now by using the parallel circuit, because we have two resistors in parallel. So that would be equal to 1 over R12 plus 1 over R3. So that would be 1 over 20 plus 1 over 30. And just use a calculator or just mental math. So I'll multiply by 3 here and by 2 in here. And we will get 3 plus 2, 5 over 60. And in reduced form, we're going to have 5 over 60 or 1 over 12. So that means that the total resistance here is going to be 12 ohms. So I'm going to write this down. So the total resistance is 12 ohms. Okay, so what comes next? So the next thing that we want to look into is the voltage. Now, because these two are in parallel, then the voltage, the total voltage, would be equal to the voltage in 1, 2, and the voltage in 3. So we're going to say that the voltage in 1, 2 is equal to voltage in 3, and it is equal to the total voltage because they are in parallel. So with this, we have found the value of V3. So I'm just going to cross this out, and I'm going to say that V3 is equal to 30 volts. Now, V12 is also equal to 30 volts, but I have to find V1 and V2 in the meantime. So remember that when in series, because V12 includes these two in series bulbs, right? So when in series, the voltage drops are different for each bulb. And for this, we will need to know what the current is in this case, okay? So now that we know the voltage and the resistance in each part of the parallel circuit, we can find the current in each of them. So I'm going to start with I3, which is V3 over R3. That's easier to find. That's 30 divided by 30, so that would be 1 amp. So I'm going to write that down. We got I3 equals 1 amp. Now, next we are going to find the current in R12. So in the whole thing here. So the current in 1,2 will be V12 over R12. So that would be 30, because again, remember, these are equal to each other. V12 is equal to V3 equals V total, which is 30, right? And we're going to have 30 divided by R12, which is 20, so that's 1.5 amps. Now, remember that the current when the bulbs are in series will be the same in both of them. So we're going to say that I1 will be equal to I2. It's going to be equal to I12, which is their total, or 1.5 amps. So I'm going to go back here and I'm going to say I know, oops, this was I3. Sorry, I placed it in the wrong spot. So this is going to be 1.5 and this is going to be also 1.5. I like it when I jot the information down because it's a lot easier for me to figure out, okay, what step to take next. Now, we have all currents, we have all resistances, and we need to find now V1 and V2. So that shouldn't be that hard. I know that V12 is 30 volts. We studied this a little bit earlier. So V1 is going to be R1, I1. And look, we have the numbers organized, so it's a lot easier and faster when you write the test, so you don't have to actually wander around, so where each part of the solution is. So 14 times 1.5, and that will bring us to 14 times 1.5. Obviously, we can do that in our head as well, but there we go. V1 equals 21 volts, so we got V1 as well. And V2 will be R2 times I2, and R2 is 6, remember? And I2 is the same as I1, so it's 1.5, and 6 times 1.5 is equal to 9 volts. So we got 9 for this. All right, and now we have to find which one is the brightest. So if we want to find or determine the brightest bulb, we have to find the most powerful bulb. So that is found by using simply P equals I square R, and I'm going to start with P1. So that's 1.5 squared times 14. 1.5 squared times 14 is equal to 31.5 watts. P2 is equal to, again, we have I2 squared times R, which is 6. So 1.5 squared times 6, this doesn't seem to be the brightest because apparently the resistance is lower than the previous. So that's 13.5 watts. And P3 is equal to, so we have the current in 3, which is 1. We have the resistance, which is 30. So that would be equal to 1 squared times 30, which is 30 watts. So it seems that the brightest will be the first bulb, the R1, with resistance R1 of 14 ohms. And next, we're going to take a look at the another problem very similar to this, but a little bit longer. Thank you for learning with me. Bye for now.